I'm Myrna Beldemillo. School's out, it's time to have some fun. Why not add a little science to your summer? Science and You starts now.
I'm Donna Hanover. Could square wheels on a tricycle really work? They can if you've got the mathematics down. That's ahead on Science and You.
I'm Andrew Falzon. Learning design is a hands-on process, and here at the New York Hall of Science, they're teaching kids the link between design and math. That story's coming up on Science and You.
I'm Anne Riddell. Ready for your lesson in gross biology? We'll introduce you to some pint-sized scientists ahead on Science and You.
I'm Tinabeth Pina. Although school is out, learning about science is in, and we'll tell you why coming up next on Science and You.
I'm Mike Gilliam. When it comes to summer fun, there's lots of cool stuff you can do. You can go out and see a movie, or maybe take in a concert, or see a Broadway type show. That's not what these guys are doing. They're all going inside to learn about bubbles, and you will too. It's straight ahead on Science and You.
Hey, this is Lisa Beth Kovitz on Long Beach. Today we're going to look at the synergy of science and surfing. Ahead on Science and You.
I'm Barry Mitchell at the Central Park Zoo. Today we're going to meet a scientist who chucked it all for a life in comedy. Dr. Tim Lee, coming up on Science and You.
I'm Donna Hanover. Fractals are easier to understand than you might think. Square wheels are really a possibility, and a hyperhyperboloid is actually kind of fun. You find all that out at the United States' only Museum of Mathematics, nicknamed MoMath, here in New York City. It opened in December 2012, and co-founder Glenn Whitney, who taught math at the University of Michigan and did mathematical analytics for a financial services firm, says math has the element of surprise.
The basic thing we want to show is that mathematics can make something that seems to be impossible actually be possible. So there's a mathematical principle called a theorem, which has been proven beyond any doubt, that you can take any shape whatsoever, and there's a road for every wheel. So I thought, what better shape to demonstrate it with than with a square? We could make a road where it'll roll as smoothly as a round wheel will on a flat road.
Did you believe that you could have a square-wheeled tricycle?
No, I didn't. It's crazy.
And there's a couple other math ideas in here also. First off, if you look at these trikes, you'll see that every wheel's a different size. Well, why should that be? And that's a lesson that each one is going around at a different radius, and so kids can understand that you need to make the wheels different sizes if they're rolling, because the circumference depends on that radius.
Another exhibit people love is called Math Square, which can be set up with different games.
It's an in-floor LED display, like a Jumbotron, but put horizontal on the floor. And not only that, but it senses the location of everyone who walks on it. And as far as we know, it's the only position-sensing in-floor video display anywhere.
But what about all the X's and Y's and powers and exponents that people associate with math?
So what this exhibit actually is a gallery of different formulas. Every point in space you can associate with three numbers, what's called its X, Y, and Z coordinates. You plug them into this formula, and if the answer comes out to 0, we say, okay, we're going to put a colored dot on the screen, in that spot. And when you collect up all those colored dots, you get these beautiful shapes, and then people can transform one shape into another using this lever. And that's why we call it formula morph. And that's kind of amazing that even a shape that seems sort of complicated like a heart can have a simple formula that determines it.
Co-executive director Cindy Lawrence says helping people see past 2 dimensions into 3 dimensions is what's behind the laser display called Wall of Fire.
So we have a cylinder here. You can see that if we slice this, we would get a bunch of circles. What's very surprising, though, is that there is a way you can slice this and end up with a rectangle, which seems impossible because it's round. But yet, if we hold it in just like this, suddenly a rectangle pops up.
In other areas, people can see the paths different shapes take as they roll, do puzzles in the Enigma Cafe, and check out the hyperhyperboloid chair.
In its initial state, all of the red and yellow strings are straight up and down. But as I rotated around, the strings went on different angles, and what you can see is I'm now inside something that's lovely and curved, but yet any one of these strings is still exactly a straight line.
And you can experience fractals at something called Human Tree.
Your arms have been replaced by another copy of you.
Oh.
Similar structures being repeated at smaller and smaller scales.
At MoMath, you can even see how music and math are related.
Each one of these spheres stands for a different 3-note chord that could be used in music. So for example, this one right here is a major chord, and this one here is a minor chord. And you can hear that that one sounds a little more somber. And so what makes up a chord? What is the important aspect of it? It turns out it's the spacing between the notes. How different the first and second notes are in pitch, and how different the second and third notes are in pitch.
It makes me want to learn math more math that's hands-on. A lot of museums don't touch because it's very valuable. This stuff is valuable, but it's great that you can play around with it. You always have fun stuff to do here.
Do you think you're learning about math?
Yeah, definitely.
This may seem like kid stuff, but adults love the museum too. Prominent mathematicians regularly give lectures here, and they're delighted to have what lights up their lives, exciting other people as well. I'm Donna Hanover for Science and You.
I'm Andrew Falzon. Mini golf is a great way to spend a summer afternoon here at the New York Hall of Science. But if you want to get your creative juices flowing, you can head inside. The museum has an exhibit called Design Lab, which teaches kids about the connections between design and mathematics. Back for a second summer at the New York Hall of Science, Design Zone is an exhibit that allows kids to learn in an environment that is totally hands-on and interactive. Truck McDonald is a training specialist with the museum's education department.
Well, Design Zone exhibit was originated from OMSI, Oregon Museum of Science and Industry, and we got the exhibit just a few weeks ago. And the exhibit is basically a way to show kids how math can be integrated into everyday life and how it can actually be interesting.
Each exhibit includes a detailed description of the math or science concept it demonstrates. Part of the goal is to show kids that math really isn't so bad after all.
A lot of times when kids hear the word math, especially when it comes to algebra and things like that, they think negative connotation, so they think bad, hard, difficult, things like that. So we try to make sure that they understand that it can be applied in a lot of different places and it can be fun and easy.
The exhibit includes about 20 stations that are broken down into 3 categories that include music, art, and action. The art section includes the Build a Plaza station, where kids use simple colored building blocks to learn some complex math behind the patterns that emerge when constructing buildings. A video game called Marble Maze shows kids that variables in math equations are more than just X's and Y's. In addition to using a table-sized controller to play the game, players can set different variables in the game to make it easier or more difficult.
In algebra, they see X and Y and they see that variable, and it's something that you really can't control, can change. But here, our variables can change, right? So we have the bounces of the ball or the size of the hole, and they can change that, and that can determine the outcome. Just like if we change X and Y in the equation, that can determine what that equals in the equation, right? So we can change variables in video game and in algebra.
Design Zone also allows kids to explore and create music. The wackophone includes a series of 8 color-coded pipes. Each plays a different note. Color-coded sheet music guides wackophone players who have to guess what song they're playing.
The longer pipes are going to have a lower pitch, right, sound, and the shorter pipes are going to have a higher pitch. And that's because sound is basically vibration. So we're going to have, each pipe is going to make a different vibration.
Even the big kids wanted a chance to make music with the wackophone. Jatinder Singh came with his son from Plainview, Long Island. He's one of the parents we spoke to who enjoyed the exhibit as much as their kids.
The best part is they can experience, touch things, feel things the way they want to do it at this age. Not with the instructions, restrictions, don't touch this, don't do that.
When you think of a museum exhibit, so often it's you stop and stare and look and learn, but this is very, very hands-on. It's perfect for summer.
Yeah, it's great. Well, that's what our museum is all about, hands-on exhibits. So what we do is promote the hands-on learning because we think that kids learn better when they get to touch and interact.
When the kids work their way through the design exhibit, there's another kid-pleasing attraction that's perfect for a summer day. After a long day of design and number crunching inside, parents and kids can head outside to the science playground. It's another 30,000 square feet of hands-on interactive science exhibits, which means while the kids play, mom and dad can sit on the sidelines. I'm Andrew Falzon for Science and You.
I'm Anne Riddell. Biology might sound like a complex topic for children as young as 4 years old, but even tiny scientists can handle big concepts when they're fun and a little bit gross.
Shake it all you can, shake it like a milkshake, and do the best you can. Oh!
Don't let the adorable song and angelic faces fool you. What's coming up in this class is pretty gross.
What is this? What just happened?
Welcome to Gross Biology at the Children's Museum of Manhattan. On today's syllabus, vomit. It's a science lesson that captures kids' fascination by explaining why the body works the way it does. And for this crowd, the grosser, the better.
What happens sometimes if you feel sick?
Then you throw up.
You learned about that, right?
Mm-hmm.
What do you think of that?
Kind gross.
I remember acid is special because it makes the food really small.
While the gross factor may be the hook here, what's really happening is a lesson on the digestive system in terms children 4 to 7 years old can grasp.
We're trying to make science as accessible as possible, not as something daunting, and something fun as well for even a child of 4 or 5.
We're going to add some of the color that you get in the intestines.
For adults, this may bring on unpleasant memories of a stomach bug, but for kids, one of the class highlights is making, yes, you guessed it, fake throw-up. In this case, with ingredients like oatmeal, applesauce, and paint. Seeing the mixture churn and bubble makes the lesson tangible in ways that just talking doesn't.
We're explaining the functions of each part of their body and why it's really important to take care of each part of their body. In every single lesson, there's an explanation of like why we need to brush our teeth, or why it is we might be feeling sick, or what we need to eat to have a healthy digestive system.
Proving the saying that children are resilient, the group moves seamlessly from, here's the word again, vomit, to snack time, and then back to, well, you know what by now, in an art project that wraps up what they've learned and gives them something to take home, much to their parents' delight.
It sounded like he had a blast. He came right out and showed me exactly what the project he made of what he ate and then what he threw up or vomited. We've been coming to classes here for a couple of years and just are thrilled with the classes.
While we grown-ups might not relish a lesson in gross biology, for a lot of kids it's pretty cool. And as the educators here point out, that's the magic, harnessing children's natural curiosity and teaching them science along the way. I'm Anne Riddell for Science and You.
I'm Tinabeth Pina. Science in school may sound boring, but that's when Mad Science Summer Camp step in and turn learning into fun.
What I have?
Oh, wow.
I got 6.
What do you think that one is?
These kids are excited about Mad Science Summer Camp, a science program that lets children become junior scientists for the summer and embark on a series of science adventures.
The kids are seeing things and doing things hands-on and not just being given information. They're learning as they're doing.
What you got is hot water, dry ice, food coloring, and baby shampoo.
When I learned earth science, you had to sit there like this is a rock. Let's talk about a rock for 3 weeks, you know, things like that. But with us, it's, you know, come in, we're going to talk about this for a few minutes, we're going to play with it, you're going to do it hands-on. You're having fun with science as opposed to having to sit there, take a test about it, take a quiz about it.
Ranging in age from pre-K to 6th grade, kids and parents have a variety of choices about which science programs work best for them throughout the summer.
They could take 1 week, they could take multiple weeks, they can do a different topic every single week, they could take their entire summer. That's completely up to the kids.
The science camp is really fun and interesting. You can learn a lot.
I think it's something fun that they should do. He has a lot of good experiments. When you blow in carbon dioxide, it just pops up in your face.
From chemistry to forensics and everything else in between, kids will touch, see, hear, smell, and taste what science is really all about.
We use jokes and things and make it fun, and then they get to do it themselves. And then every day, also at the end of the day, after we've done all these experiments, they get to take something home related to what they did in the class.
So it's homework, but it doesn't feel like homework.
Right, it's definitely not homework. It's like a tangible thing that they're very excited to take.
This approach to teaching science is aimed at encouraging more kids to pursue the STEM fields: science, technology, engineering, and math.
We're trying to get their feet wet. And I know a lot of schools are doing, they're cutting sciences and arts from their programs. So this is just a great way to get the kids introduced into science in a way that they normally wouldn't. And hopefully that just sticks with them.
If the kids' reactions are any indication, a career in science may be just a few years away.
I want to be a dinosaur scientist.
Yeah?
Yeah.
You have an interest in dinosaurs? What is it about them that you like?
I like how they look and how their bones feel, and I put them together sometimes.
If by chance you miss out on a camp, try a Mad Science birthday party instead. For Science and You, I'm Tinabeth Pina.
I'm Mike Gilliam. Did you ever have fun in the summer making bubbles? Well, what's going on in here is the ultimate in bubble making. It's called Bubble Mania. Let's take a look inside.
Please welcome Bubble Master, Casey Carl.
His name is Casey Carl, the bubbleologist, and he does some amazing things with bubbles while focusing on science.
Brain power beats battery power. Walk the wire. Walk the wire.
Carl says his show is a combination of science, art, and comedy. He started back in 1987 with the Ringling Brothers Barnum and Bailey Circus, and has done his Bubble Mania show over 1,000 times for audiences like these students in Ridgefield, Connecticut, and on the Discovery and Science channels. Science has always been a love.
I discovered soap bubbles as a form of entertainment and comedy in the circus, and for 22 years now, it's been a full-time occupation.
He teaches.
I can do that trick because I know with my brain that a bubble is simply trapped air. A basketball is a kind of bubble.
Here's a lesson on bubbles being spherical in shape.
I learned bubbles around because they're part of nature. Being spherical is their natural shape. This shape uses the least amount of surface for trapping the air that's inside. It's using the least amount of energy.
Sometimes he'll turn a lesson upside down. Here he uses a sugar-based vapor to make his point. So how does he manage to make bubbles which are thinner than a human hair so strong?
The answer is the solution. Solution is the term given to a mixture of different kinds of liquids, in this case soap and water. Solution, it's a science word. Everyone say it. Solution!
So, what's the solution?
A good basic solution would be using dishwashing liquid, quality dishwashing liquid, distilled water, I emphasize distilled water, and something called glycerin. Many people know it as an ointment for skincare. It also slows down the evaporation of the water in a bubble. Glycerin, it's in a lot of products to hold moisture in those products. A lot of people make an assumption that a soap bubble is actually a stronger version of water. In fact, it's weakened water. Water has such a strong adhesive quality that you need to weaken that adhesive force in water molecules so that they will stretch and become elastic.
Rubber gloves are also important because they keep the oils and other contaminants on the skin from breaking down the bubbles. And your hands must be wet. Dryness breaks bubbles.
Keep your seats blue. It's time for the big boys to come out and play. Hug me, Bubble, hug me. Oh yeah! I will be placing a quiet, seated, smiling volunteer from this audience inside a giant bubble. On 3. 1, 2, 3.
Bubble Mania, that's a wrap. Aw, come on. You know you want to see one more.
I'm going in. You can't stop me. I'm going in.
I'm Mike Gilliam for Science and You.
Tinabeth Pina for Science and You here on Long Beach to talk about the science of surfing. Surfers may be laid back about how they spend their day, but make no mistake about it. You gotta be smart and you gotta use some science. I visited with a surfer and a surfing scientist to get the lowdown on New York City's surfing secrets.
A lot of places, especially on the East Coast, because of the way the sandbars break, at high tide it's breaking right on shore. That is not indicative of a good surfing break. A very good example of a surfing break would be someplace where you have a reef.
In the tropical islands where we have the best surfing waves in the world, we have coral reefs. Those reefs intercept the wave energy at an angle, and it helps that wave break and roll across the reef. And that's something surfers really like because the length of the ride is very important. So the more rolling, the more riding.
Or of course when it gets big, it hits deep water, it hits the reef, it shoots up. That's where you get big pipeline waves.
Pipeline is a very specific name given to a very specific surf break in Hawaii. And that's because the wave there, when it breaks, it's so shallow over the reef that it always breaks as a tube. Basically, the wave crest is thrown out in front of the wave, and it creates this really big hollow tube. So the surfer actually gets covered by the wave, and that's why it's called a pipe. We do get them in this region of the New York metropolitan area, and we get those waves typically during hurricane season. When we have hurricanes moving up the coast, we can get those conditions. But it's very rare and it's very short-lived. Waves will break very differently depending on the bottom that they interact with. So if we have a very broad, shallow seabed with a little bit of a slope, those waves will move and they'll lose energy as they move towards the coast, and they kind of spill over. They dissipate their energy very slowly. If we have a very steep shoreline, like the west coast of the United States, well, all that energy hasn't been lost as it gets to the coast. So those waves give up all their energy at once, so they break higher and faster. For how complex we think waves are, they behave very, what we call linearly. You can solve them easily.
Are you saying that there's a mathematical formula to make a wave break?
It's a very simple formula, as a matter of fact. A wave will break when it reaches a water depth of 2/3 its height. So the equation is simply breaking height, h, is equal to 0.78 times the water depth. And that'll give you the size of the wave that you can get.
What makes Long Beach a particularly good place to surf?
Long Beach sits close enough to the Hudson Canyon, which is the underwater valley that the Hudson River used to flow through. So it's very deep water. So the waves moving up the canyon move very fast, and when they get to Long Beach, they're bigger usually, and they break longer. So it's kind of in the perfect spot for surfing. Well, most of the geography in what we call the New York Bight, the New York, New Jersey area offshore, is pretty flat and shallow. But because the Hudson Canyon comes into New York Harbor, the closer you get to New York Harbor, the quicker that slope drops off to really deep water. So it's pretty complex, and we get some really strange wave movements in there.
Tom, as a surfer, what do you look for when you head out for the day?
Not a lot of people. That's what I typically look for.
And as a scientist, do you have any secrets for surfers that they should know about?
Secrets? Get up early.
Thanks so much for talking to us. This has been Tinabeth Pina for Science and You.
I'm Barry Mitchell at the Central Park Zoo with Dr. Tim Lee. Nice to meet you.
Nice to meet you, Barry.
The oil companies are giving out gas-saving advice that they know you're not going to use. Did you know if you drove 55 instead of 65 on the freeway, you could get an extra 30 to 60 miles to the tank? Which is true, because you would actually get pushed forward by the honking noise.
How does one give up a career in science for the life of a comedian?
You get tired of reading and writing papers, and you decide to do something else. Science is straight logic, and comedy is twisted logic. So it wasn't that big of a difference for me. And the speaking part was pretty easy, because I used to give talks in front of smart people who try and pick apart my logic, and now I give talks in front of drunk people who try and pick apart my jokes. So, pretty natural transition.
And your field of expertise was?
Ecology and evolution. I did mostly mathematical biology. So,
explain what that is.
It's like population dynamics, trying to estimate population sizes is one of the things
I helped work on with the seals.
Sea lions and oceanography figures into your past before you became a comedian. Tell us.
That's right, I was a biologist. I worked actually for the National Marine Fisheries Service at Scripps Institute of Oceanography. And we worked on, among other things, Xylophus californicus right here, the California sea lion. And they're an amazing animal. They were endangered at one point, hunted to near extinction for their skins and oil. But they've made a comeback. They struggle with two major predators, which is the great white shark and then the killer whales.
So you weren't observing them in a tank like this, you were observing them in the wild?
Yeah, in the wild, out of the Channel Islands and anywhere along the California coast, yeah.
My porta potty behavior determined entirely by this ratio.
How did you hit upon the idea of using PowerPoint as one of your props?
A lot of the times people don't understand the premise of the joke that we're trying to make, because science can be obscure for some people. So with PowerPoint, I can explain to them the principles, and then they can get the joke I want to make.
Young women also start off in a superficial stage, at which point they put a 90% weighting on social status, a minus 10% weighting on personality, 20% weighting on the car the guy drives.
Who is your audience?
My audience, I think the youngest, sort of fan would be maybe 14, 15, and then all the way up in the 70s, 80s. People who are a little bit nerdy, even if they don't look nerdy, they think nerdy, and they have an interest in science. I don't want my comedy to appeal to everyone because I think Bill Cosby said it best. I don't know what the secret to success is, but the secret to failure is trying to appeal to everyone. And if they like me, they like me, and if they don't, they don't. That's part of being an artist. I started off in the open mics in San Francisco. I started off at a laundromat that had an open mic, and which is actually the ideal place for an open mic because no one wants to listen to a comic when he just starts. The people doing their laundry have no choice but to listen. I finally moved up to the comedy club in San Francisco, which was the Punchline. And now I travel all over the country.
4.5 billion years ago, we saw the formation of the Earth from the explosion and collapse of a star that subsequently became our sun. 1 billion years after that, 3.5 billion years ago, we start to see the very first fossils in the fossil record, which are assumed to be some form of anaerobic bacteria. 3.4 billion years ago, Larry King hosts his first talk show.
It's been great talking to you.
It's been great talking to you, Barry.
And I can see that your act has the seal of approval. Our thanks to the Central Park Zoo and to Dr. Tim Lee. If people want to know about your upcoming shows, where do they reach you?
You can find me at youtubecomedian.com. It's got my schedule, and you can get in touch with me if you want to.
There you go. And I'm Barry Mitchell, and you're watching Science and You.
That's our show for today. I'm Ernabelle DeMillo. We'll see you next time on Science and You.